Continuing with the same population of 5 values that we started with, we can now proceed for sampling with replacement technique. So how do we apply sampling with replacement technique? Let's assume that we need to write down 5 values given in the population as 80, 82, 85, 88, and 90. We are dealing with the same numbers or same values for which we have already computed the population mean mu as 85 and the population variance as 13.6. This is what you can find out, you can watch in lecture video number 1 of the same series. So sampling distribution 1 is the title of that video. Now, in sampling with replacement, let's assume these 5 numbers or numeric values as the first 5 alphabets of English language: A, B, C, D, and E. What we have done in case of sampling without replacement, we have followed a strict dictionary order to list all the samples like this. Starting with A, the second alphabet is B, can be C or D or E, then B with C, B with D, B with E, then C with D, and C with E. Now continuing with the same, when we work with the technique with replacement, so the same letters or alphabets can be drawn in the reverse order as B with A, here B comes first and then A comes as the second alphabet. Similarly, B, A, C with A, we can write down this in the reverse order. In fact, all the samples we can write down in the reverse order, and this is how we get 10 more samples to be drawn when we follow the technique of drawing samples with replacement. We can also draw the same 2 alphabets together. Let's assume that first slip we have drawn and we have noted down that alphabet as A, and if we put it back to the log, so there is a possibility that A can be redrawn. So for this reason, we can get A with A, B with B, C with C, D with D, and letter E with E. Now, this first list of alphabets we have done already in case of sampling without replacement, and if we synchronize this with the numbers that we have assumed for A, B, C, D, and E as 80, 82, 85, 88, and 90. So we can in fact list the samples like 81 with 80 with 82 as the first sample, then 80 with 85, then 80 with 88, and 80 with 90. Then we have 82 with 85, 82 with 88, 82 with 90. Then it starting with 85, 85 with 88, and 85 with 90 would be the other 2 samples, and the last one would be 88 with 90. Now, what we have seen when we have worked out the sample mean values, this is 81, that's 82.5, that would give you 84, this is giving us 85, this would give us 83.5. This sample has a mean value same as the fourth sample 85. Then this would be 86, then 86.5, then 87.5, and then 89. Same samples we can get in the opposite order, reverse order. So order doesn't matter over here as far as mean value is concerned. So we get the same value of mean 81 when we rewrite down it as a new sample starting with 82 and the second one is 80, then 85 with 80, then 88 with 80, then 90 with 80, then 85 with 82, 88 with 82, then 90 with 82, then 88 with 85, then 90 with 85, and then 90 with 88. So writing down the same values in reverse order will not affect the mean value, will not change the mean value. So 81, 82.5, 84, 85, 83.5, 85, 86, 86.5, 87.5, and 89. Furthermore, these five samples would give us 80 with 80, so it would give us 80 as the mean value. Then 82 with 82 would give us 82 as the mean value. Then 85 with 85 would give us 85. Then 88 with 88 would give us 88, and 90 with 90 would give us 90 as the sample mean. So if we would like to construct a frequency distribution for this entire set of values, we can notice that we have ended up with 25 samples. This we can refer as the list of sample mean values, what we have got in sampling without replacement already. Same numbers or values of the mean will reoccur. So we get this 10 values again, so 20, and these 5 values in addition to the 20 samples. So 25 sample means we get. Now if we start tallying with the minimum value, that's 80, is the very first possibility. What I'm doing, I'm writing down the mean values in order. Then 81. So if we tally the frequency side by side, then what we are getting as the mean value, 80 is occurring once, then 81 is occurring twice. So we cancel out this to tally. So there are two 81s that are appearing in the list of sample means. The next one is 82 in order. It is not necessary to follow an order, but I am preferring to write it down in order. So 82.5 is occurring twice, one over here, another one over here. Then 83.5 is the next sample in order, which is coming up in the list twice. Then 84 with 84, so there are two 84s. Then if we go to 85, so 1, 2, 3, 4, and this is the fifth one. Then 86 we have once, twice. Then we have 86.5. Again it is occurring twice. Then 87.5 we have, again 2 is the frequency. Then we have 88 in order, occurring once. And then we have 89 twice. And then 90 is coming up once in the list. So this is how we get 25 samples.